Number 9, the question reads, for time t greater than or equal to 0, the position of a particle traveling along a line is given by a differential function s. If s is increasing for 0 to 2 and decreasing for t greater than 2, which of the following is the total distance the particle travels for the interval from 0 to 5? Okay, so the key words there are total distance. S is our position function, and we know that total distance is always going to be the integral from a to b of the absolute value of our velocity function. Right? And velocity, well, that's the derivative of position. Here's the velocity function down here in option E, and we have the absolute value. The bounds we're interested in are 0 and 5, so 0 and 5. So total distance, we know, matches with absolute value. We can get this answer quickly. It's E. Number 10, water is pumped into a tank at this rate. T is the number of minutes since the pump was turned on. The tank had 800 gallons of water when the pump was turned on. How much water, to the nearest gallon, is in the tank after 20 minutes? All right, so this is the rate. We need our initial condition, which is 800, and we're going to add to it the integral from the time that we know, which is 0 when the pump was turned on, to the time we're interested in, which is 20, of the rate, and the rate is our r of t. Calculating this on the graphing calculator is going to give us our answer. So let's go to the machine. We can put r of t into y1. So we have 30 times the quantity 1 minus e to the negative 1600th x. Now we want that in our integrand. So we're going to go back to the main screen. We're going to do 800 plus, and the 800 is important, math 9. We're going to go from 0 to 20, and we have our function located in y1. And we see to the nearest gallon it's 1220. Right? So our answer is going to be D. But notice answer B, 420. For students who forget to include the 800, they will incorrectly be circling that value. With number 11, the rate of change of the altitude of a hot air balloon is given by r of t equals t cubed minus 4t squared plus 6, and the interval is 0 to 8. Right? So a hot air balloon is rising, it seems like. Which of the following, or maybe it's falling, who knows, which of the following expressions gives the change in altitude of the balloon during the time the altitude is decreasing? All right, so the altitude is decreasing when the rate is negative. So let's figure out when that rate is negative. And to do that, we need to go back to the graphing calculator. The altitude is going to be decreasing when the derivative, the rate at which the altitude is changing, is negative. All right? So we're told that the rate the altitude is changing is right here, t cubed minus 4t squared plus 6. So I'm going to bring in the calculator and I place that into y1. Now we're interested when this function is negative, because we know a function in general is decreasing, and that's what we're interested in, the altitude to be decreasing when its derivative is negative. So when is this function negative? And again, our domain is 0 to 8. So we're going to hit the window. We want to make sure that we have an x-min of 0 and an x-max of 8. The y-min and max can be numbers that are pretty close to 0 because we're interested in finding out when this function drops below the x-axis. So now we go to the graph and we see this picture right here. So we can clearly see the interval in which our derivative is going to be negative. We just got to find those exact values. Now, again, if we're using our common sense here, this is 1, this is 2, this is 3, this is 4. So this is 1.5, this is 3.5-ish in both cases. Look at your 5 choices. Only 2 of them have the bounds of 1.5-ish to 3.5-ish. So our answer is going to be one of these two. Right? So now the question is, should it be r prime or should it be r? Well, r is not stated as a derivative, but we realize it's a derivative because we're told it's a rate of change. What is it the rate of change of? The altitude. So we're interested in the total change. We want the total change in the altitude, which means we want the integral of the rate of change. And r is the rate of change, which means we want the integral of r, not r prime.